So in this video we'll try to see the FreeRTOS port. Basically we'll do it from starting. We will download the FreeRTOS kernel, and then we'll see how we can build the FreeRTOS library, and then that FreeRTOS library, using that FreeRTOS library we'll build the kernel image and try to create some of the threads. Okay, at least those threads should be scheduled, so those things we'll try. Okay, so right now I have gone to this GitHub repository where we can get the FreeRTOS kernel. Okay, we'll download the zipped version of this FreeRTOS kernel. Okay, once we have downloaded, let's go inside the download folder. Let's unzip it. After unzipping, we can see there are a lot of files. Okay, so we'll try to pick the files which is needed to build the FreeRTOS library. Okay, our first objective is to build the FreeRTOS library. Then that library we will use to basically build our kernel image. Okay, so this also we'll try to build on top of whatever we have developed, the bare metal. So bare metal code I have already explained in my previous videos. All this code base I have already explained. Okay, so now let's create one folder here, not inside src, at outside. Okay, outside we'll create one folder. That folder name will give FreeRTOS. This folder we want outside. Okay, let's delete this one, and we'll create from that command. So make directory FreeRTOS. Okay, so FreeRTOS is ready. So here let's first see which all files we have to copy to this location. Okay, so here we can see there are some examples they have given by default, and include header files, and then based on which kind of what is your target SOC or target platform, based on that they have given a portable folder. So inside this basically we have to go for the GCC and ARC64. Okay, so inside this we will be needing this port C, port ASM, port macro. So these three files we will be using, and apart from this portable, we need one memory management unit. So that memory management unit means how to manage the heap. They have given total 5 options, and you can use any of the 1 options. Each options has some advantage and disadvantages that I'm not going to go inside that. We'll try to use one of the heap allocation method, which is heap 4. Okay, so in portable folder we basically need those portable files, memory management. Okay, apart from that, other files which we need is we will be needing these C files to create list, timers, tasks, string buffers, queues. So these are the parts of basically FreeRTOS OS. So these files we need. Okay, so let's start copying one by one these files to our FreeRTOS folder which we have created. Okay, so let me create one src, one include, and one portable directory inside FreeRTOS. So let's create one src, then go inside FreeRTOS ls. We have created src. We have to create directory include folder. Okay, and other one is we'll create one portable folder. Okay, so include folder we'll copy whatever is here. We'll see later which all files we have to remove later. Okay, let's copy it first. So inside FreeRTOS let's paste it. Okay, directly it is not giving. So what I will do, I will open one more window, and directly will copy to that place. Play with bits FreeRTOS inside source. Okay, let's first move the source. So inside source we need C routine event, event group, list, queue, then stream buffer, tasks, and timers. So all these things will copy and paste it here. Okay, the src is done. Then next we have to check include folder. So include folder, I'm trying to maintain the same directory structure which is present in the actual kernel code. Okay, so we have copied into src at the same level we have include. So inside include we'll copy all this files. Okay, now after this what else we need? We need portable. So inside portable we have not created here portable directory, so let's create one more directory, portable. Okay, inside portable we will copy GCC. Okay, what we can do, we can copy this first memory management. Inside portable there will be one memory management, and GCC also will copy. and after that I will delete whatever is not required. So from 1 to 3 we don't need this, so this one will delete, and this one also I don't need it, move to trash. Okay, so memory management is right. Now inside GCC we have lot of other folders for supporting the other different kind of architecture and different kind of platforms, but we are only interested in this ARM architecture 64. Rest of the folders will delete. Okay, so let's delete this one, and after this till end we'll delete everything. Okay, so this folder is also now ready. So as you can see, we have created almost everything. So whatever is needed from the FreeRTOS kernel, we have successfully put inside the FreeRTOS folder. Now we have to build the library out of this FreeRTOS folder, and then that library we will try to basically link with our kernel. Okay, so now let's close this file and let's go here. So here we have included inside FreeRTOS. So now let's open the make file. We'll try to now build the FreeRTOS library. Okay, so to build the FreeRTOS library, our target is to build the FreeRTOS lib, right? So let's define that, and one by one we'll see how we can build this library. Okay, so let's first define the FreeRTOS library as a one variable FreeRTOS lib, and that will consist of free okay, so it should go no, but this should be creating inside FreeRTOS inside build folder. Okay, that will be created inside a build folder. Okay, and before that build folder, do we have to make any do we have to create the build folder first? That also we'll check. Okay, let me check first. Yeah, so basically we have to create this build folder first. Okay, okay, so okay, we'll fix if there is any issue which will come. Okay, during that time we'll fix it. So FreeRTOS library. Okay, so this one will tell the FreeRTOS library. Now we have to build the FreeRTOS lib. Okay, so let's define how to build the FreeRTOS lib. Okay, so to build the FreeRTOS lib, basically we have to define FreeRTOS. Okay, correct. So FreeRTOS lib we have to build it, and that will build from the FreeRTOS. Okay, so now after this we have to also tell about the source files which is needed for the FreeRTOS. Okay, so all source code files that we also have to define. Okay, so let's define that here. So FreeRTOS C files. So FreeRTOS C files is inside okay, this is wildcard entry FreeRTOS, then src will be inside src and .c file. Fine. And FreeRTOS objects file, FreeRTOS, before that we have to, this is FreeRTOS C files, we have to define the portable C files also. Okay, so FreeRTOS portable C files. Portable C files are inside the FreeRTOS portable GCC. Okay, I just wanted to check whether we have any .assembly file also inside this. Yeah, so we have to define the FreeRTOS port ASM file also. Okay, so let's first define FreeRTOS port C file. Let's port C is done. Now port ASM files. So port ASM files is also included. All the okay inside that. Now we will include the memory management files. Okay, FreeRTOS, then memory C file, that also we are included. So basically, do we have any C file inside memory management? That's what let's check that once. No, nothing is there. Only port C, port ASM is there. So C files is there, this is done. So basically we have included almost all the files. Now apart from this we have to also FreeRTOS header files. So header files also we need to include. Okay, so for that let's add the header files. FreeRTOS header files. So FreeRTOS header files are inside FreeRTOS include.h, FreeRTOS include.h, and then another is we have some headers inside this one also. Okay, we have some headers inside ARM64. Inside that also we have inside memory management also we have some headers. No, we don't have any headers inside memory management. Okay, so this part we can delete. Okay, so till here it is done. So now we have to using this, basically we have to build build the FreeRTOS library, right? So uh, let's first combine these to build the object files. Okay, so all our C files, object files, everything will be combined, and then we will uh, build the object files. Okay, uh, let's go to the control and that object file, let's first define the object file. Okay, so we have to define the rules to build the object files first, and then uh, okay, then we'll use that object files to build the FreeRTOS lib, correct? So now let's define FreeRTOS object files. Okay, so FreeRTOS object files. Okay, so we basically have to include C file, FreeRTOS C files inside from the FreeRTOS C, and we have to create a .o FreeRTOS port.c files, and then port asm dot files. Okay, so then memory management files. This one is also okay. This one is also okay. So this all will be basically FreeRTOS object files. Okay, FreeRTOS object files are done. Now this FreeRTOS object files, we have to basically use this to build our FreeRTOS starting. Okay, so we have to basically create FreeRTOS inside. Let's create now we have to give this object file as a dependency, and then we have to give this since armgnu is already defined, right? Armgnu, so armgnu tool AR tool will use to basically build this library. Okay, so let me write it first. Armgnu AR, then we have to use this RCS flag, AR flag to build this. Okay, after building this yeah, this one we don't need. Okay, so this will build the FreeRTOS library. Okay, so now maybe before that we have to create the let's write some message. Okay, at echo for building FreeRTOS library, correct? Okay, now we have to create make directory also, make directory, correct? Now let's try to build the FreeRTOS library first. Okay, make it clean from inside FreeRTOS with there, right? Make kernel image.img. So now it is showing some error. What is no rules to make the target C routine? Okay, C routine. What happened? I am not added C routines. FreeRTOS build C routine.o. FreeRTOS build C routine. FreeRTOS builds inside. Okay, so basically it is asking for the asking for how you are building the FreeRTOS object files. So FreeRTOS object files we are building like this, right? Where we have included the C files, ASM files, and everything. Okay, so let me see how we can solve this. Okay, so how to fix these errors? I think it is saying that we are not able to build. Okay, I think we have not added the rules to build compiler options to build this basically. Okay, so let's go there. We are not going. Okay, so these things we have added. Now let's add compiler options. Inside compiler options we have to add this. Okay, so we have to add -i. We have to first include this include the FreeRTOS. FreeRTOS we have to include first -i, then FreeRTOS include, then we have to add FreeRTOS portable GCC ARM64, and then portable memory management, and this is compiler options. Inside include what about GCC, what about inside SRC, and codes which are there inside SRC, FreeRTOS SRC. So include is fine. After that you have to include -i, then we have to include FreeRTOS. Inside FreeRTOS we have SRC. Inside SRC all the files are there, right? So that also you have to add. Inside FreeRTOS we have include is fine. Then portable, wait here, portable. Inside portable we have GCC ARM64, then port C. Okay, that one is added. Then memory management is also inside portable, and we have SRC at the top level. So we have added the compiler options for building this FreeRTOS. Okay, after this we have to define the build rules which is required to build this FreeRTOS. Okay, so let's go there and define the build rules for this. Object files is done, FreeRTOS library is done. Now we have to define the build rules for each of them. Okay, So let's define FreeRTOS slash build. Inside build we have to basically .c FreeRTOS src.c. Okay, correct. So header files, why this header? Okay, dependencies and header files, correct. So we have to create make directory, then gcc. Basically this I am adding the rules for building all the files which is there inside src. Okay, so this one is done, and after that we have to add then add rules to build other files which are there inside the ARM64. Okay, so FreeRTOS inside build c.o. Okay, portable, inside portable gcc ARM64, then FreeRTOS header files is that dependency ARM gcc, you have to use cops, correct. After that we have to same thing you have to do for memory management. Memory management also will be rebuilt, and then after that inside portable we have to do inside portable also is done. Okay, so after that we have to build the FreeRTOS object file. Okay, FreeRTOS library you have to build. Okay, so this is how we have to build the FreeRTOS library. So this one is also done. What do we yeah, this is dependent on this. So FreeRTOS library will be built, then this one will be built. Okay, so now let's try to build it again, and let's do make clean first. Make clean, and what why recipe commences before first target. Line number 13. What is happening in line number 13? Okay, these kind of mistakes we should not make clean. Okay, make clean is done, and let's now build make kernel.img. Okay, so it is trying to build. Now it is not finding FreeRTOS config.h. Okay, so which is there inside FreeRTOS.h. Let's see. Okay, FreeRTOS.h is trying to put FreeRTOS config.h. So basically this is the main file where we define all the configurations, basically all the macros which we have to include, which we have to basically include inside our FreeRTOS. Okay, while building FreeRTOS. So this file actually we have to define FreeRTOS config.h. Okay, so we'll define the FreeRTOS config, and then we'll look into other things. Okay, FreeRTOS config.h we have to define. So for defining this, I think we'll define inside that header file. Okay, so let's go to inside header file only. We'll define a new file, FreeRTOS config.h. Okay, so actually this example we can take it from one of the how this FreeRTOS config.h should be defined. We can take from one of the examples. Okay, so as I have shown you before also, we have downloaded this, right, FreeRTOS. So inside examples you can file get the example how to define this FreeRTOS config.h. Yeah, so here, right, so let's open this and then open with any other editor is not there. Okay, let me open with Vim only. Yeah, so these are the macros which we have shown, which defines the basically config for building the FreeRTOS. Okay, so let's exit from here. We'll directly open this in our VS Code, and from there we'll copy whatever is needed, else we'll remove. Okay, so let's copy this and paste it here. We have a way to paste here, or can I paste here? Okay, let's paste it from wherever we are building home, play with then we have a play with bits, then inside FreeRTOS, inside include folder, let's paste it here. Yeah, let's overwrite. Okay, so we have this FreeRTOS config.h now. Okay, so now we will see what all things is needed here, and then whatever is not needed we'll remove that. Okay, so this setting up the clock. So what is that? Config CPU clock. Okay, let it be fine, that should not create a problem. Then config tick rate. So tick rate we want to make it as a 1000, means 1 millisecond tick rate. Okay, and use preemption we are going to use fine. Use time slicing also we are going to use, that is fine. Port optimized task selection means we are not going to use. Then tickless idle, that idle we need to define the tickless idle hook also. Okay, so actually I already have this defined for the FreeRTOS. Let me copy that contents, and then that one I will directly show you which all things we need to define. Okay, so these are the things which we have defined for running the FreeRTOS on RPI 3B. Okay, so preemption we are using, idle hook we are using, tick hook also we are using. Basically we are providing the hook. FreeRTOS should use its own basically hook whenever the tick interrupt will come. Okay, and FreeRTOS has one idle task also, so that idle task will be used, FreeRTOS idle hook will be used, not I will not create it separately. Okay, so that's why I'm setting this as 1, and that tick interrupt will come every 1 millisecond. Okay, the priorities, the maximum interrupt priority I'm setting it to 32. Stack size for any of the threads, minimum stack size is 1024 bytes. Heap size I'm allocating 32 bytes, 32 kilobytes. Okay, and 16-bit tick I'm not configuring. Using mutex is we am configuring. Yes, I'm going to use mutex, so that OS while building this FreeRTOS, it will include all the components to create the mutex and all. Okay, that's why I'm setting it as a 1, and I'm also want to check for the stack overflow, so those checks also we can include. So basically we have to define this the macro, and automatically from the source file it will pick up those things to create mutex, to use the tick handler, all those things automatically it will take. Okay, so the main very important file is this file. Okay, so timer also I'm going to use the maximum priority of a timer task will be the lowest priority. Okay, so config max priority -1. So basically this will the higher the number, lower is the priority. Okay, it's like that. Okay, then queue length maximum 5 queue length I'm defining. Then task tab depth will be the double of this, whatever minimum stack size I have defined here. Okay, so dynamic allocation for the RTOS object, so this one also I've set it as 1. Static and dynamic both allocation, means task can be created statically, task can be created dynamically. During your running time also task can be created, so both I am including. Okay, though if you want to, there are some FreeRTOS APIs which you can use for getting the some status, for setting the task priority, or for getting the task priority. So those APIs if you want to include in your build, so basically those you can set it as 1. Okay, so these are the list of APIs which I am including inside my build. Delete, suspend, basically delay and task delay. So all these functions I am including in my build. Okay, once we have set all of this, then we have to define the macro, the vconfig tick interrupt, and this vconfig tick interrupt basically will be defining at in one of the file. Okay, that also I will show you. So whenever this one is set, we will replace this config setup tick interrupt with the vconfig tick interrupt. Okay, so basically instead of using that vconfig tick interrupt, we will be directly using the config tick interrupt. This is just a macro replacement. Okay, similarly for the vclear tick interrupt. Okay, the unique priorities you are setting to 32, and as I have shown you before also, the in RPI 3b we have an interrupt controller. So that interrupt controller is okay, let me show you again, is at the base of this this base address. Okay, and for all the interrupts, if you want to route to core 0, so that offset is at 40. If you want to interrupt go to set to core 1, then it is at 44, then 48 and 40c. So those things are already defined in I think this I have explained in one of the videos also. So we have a BCM2836 peripherals. Okay, so let me bring this here. So here also I think this I have already explained in, if you go through one of my videos, this I have already explained where is that interrupt. So inside introduction, if I will go at the top, so we have interrupts, interrupt sources, correlated interrupts. Yeah, so correlated interrupts we are going to use, and those registers are here. So basically 40, right? Core 0 timer interrupt control is here, so that's what we are giving here. Okay, that's what we are trying to give the interrupt controller's base address. Base address is this, offset for the core 0 is 40, and then if you want to build for the other cores, then this is the offset. Okay, after that we are defining some assert calls, so that if any error comes, we should be able to get the file name and line number of that assert. Okay, so now this we have resolved the dependency of that FreeRTOS config.h. Let's try to rebuild. It will ask for some more functions, but that we will implement as we see what kind of errors it is showing. Okay, so make clean, and then let's build again. Now it is asking for port macro.h. Okay, so that is another file which we have to basically write it, but I think this port macro.h is already available. Only thing, it is not able to find the location. Okay, so I think we have not included inside this make file. So inside this make file we have we're trying to include this FreeRTOS include, but FreeRTOS include port macro.h. So while building that portable.h, it is not finding that include. Okay, how you have added include here? Let's check how include has been added. Okay, why it is ARM64? This one is wrong, right? It should be ARM understood a RCH ARC 64. Okay, it should be this one, include SRC. Then okay, let's try to build it again. Okay, now it has successfully built, right? So you can see we are not seeing any of the error, and now we can see the where it is see the okay, list file is also created. So start is created and then master. Okay, so I want to check whether factor table is set up or not. um, bar el1 el1 entry. Okay, we are able to build, but I think that starter file I have to check, because starter file should be inside, so it's not inside source portable gcc port asm dot as port asm. Starter file still you have to basically define it. Let's see whether it is already defined or not. No, right? So right now the starter file will be taken from there. We have to modify the starter file, otherwise okay, we'll see, we'll check that. But before that I want to check the size of the build image. Okay, inside build ls-l, so kernel is these many bytes. Okay, so here this kernel.elf is fine. Now let's go to the main and create a thread, then we'll see whether it's compiling properly or not. Okay, so let's go to the main.c. Where is main.c? Yeah, main.c. So inside main.c, here we'll try to create some threads. Okay, so base type t return, and then x task create, and then we have to give the task 1, then configure minimal task size. Okay, and null task priority is task idle +1, that is fine. And then we have to send the task a priority. After that we have to send task a, pointer of task a, task 1. Okay, task 1. So after this we have to now define the task 1. Okay, this is just a creation, and let's check after creating whether it's successfully created or not. So for that I will check the return status. If ret is not equal to pd pass, then basically task creation failed. Okay, otherwise else will print task created successfully. Okay, so this now we have to create a task 1. Okay, so let's define the task a. So to define the task a, basically we have to do these things. We have to write void task 1, then no parameters. Okay, inside printf keep printing hello from task 1, and then b task delay. I don't every task should have the while loop, and inside while loop it should keep on printing, but I don't want to flood the task. Okay, so v task delay, what it will do, it will delay for 1 seconds, and then it will keep on printing. Okay, this is also fine. So task 1 is created. So now let's try to compile. I think we'll see some compilation issues because headers are not included. So let's include the header. So FreeRTOS.h is needed. Okay, task.h is also needed. I don't think C routine is needed. Let's try to build it first, and then we'll see. Okay, so let's do the make clean, and then build the kernel a.img. Now we can see that v task function is called. So why this v task function is coming here? V task function that should be named as task 1 only, right? The handler we have to give it there, and then task wait v task function, this one should be task 1, and before that we have to create that handler. Okay, last one we have to pass task handler. So task handler is your task 1. Okay, so task 1 also we have given on the right side or not. Let me see, task handler and of task 1. Now it is fine. So let's make it again. So undefined reference to x task create. So x task create is defined inside undefined reference to v task delay also. So basically we have to check where this is defined. Let's see where this function is defined. X task create. Okay, so it's defined where x task create, task.h is included. Okay, it's not able to find, linker is not able to find. Okay, so linker is not using that library. Is it let's go to the make file, and inside make file, while building ld linker kernel obj files. Where's that obj files? Okay, obj files, then we need linker.ld file. We need this lib also. Okay, so FreeRTOS.lib also should be there. Why this map is required? FreeRTOS lib is required. FreeRTOS lib is built, right? So that was required. Okay, let's try to do clean build again. Okay, so now other undefined references are coming. So these functions basically now we need to define. Okay, let's check what other errors are coming. So inside q.c, okay, there are a lot of functions. I think there is some minute include which is not getting included, and mostly it's a v-assert called. Okay, v-assert has been defined, right? V-assert has been defined in FreeRTOS something FreeRTOS config.h. V main assert define config assert. This has been defined. Is it that this is not getting included inside the file? Okay, so these many functions it is saying it is not getting included. I think mostly it's a assert called YPR we created is undefined reference to memset. Okay, so mostly it is saying that v assert called is not defined. Okay, so we have to define one file where we have to create one file where we have to define all these functions. Okay, so let's create that file in the src. Inside src we'll create a FreeRTOS tickconfig.c. okay, so let's create a new file with the name FreeRTOS tickconfig RTOS, then config.c. Okay, inside this file basically we'll add all the definitions. So for this v main assert call, let's define void v main. I think we have already taken copy v assert main called, and here we'll have two things. One thing is that constant character pointer, okay, pc file, and then a line will be there, then assert called in the file. Okay, so basically this printf will come and then while loop. So basically this assert we have defined here. Now automatically this file will be compiled, that is not a problem. But okay, that is not a problem. So let's at least that error should go away now. Assert error is now went away. Now other things which are coming is undefined reference to mem copy. So basically void v config tick interrupt, that will define it when it will give that error. Void pointer mem copy destination source, then size, then character destinations it will take. Okay, it will take as here, then for the number of size it will take it, copy it from here to here, character by character, and then return the destination. Okay, this is fine. So now mem copy is also there. Let's do clean build and make again. Okay, size t is not defined, so instead of size t we can change it to, either we can include itself standardly, or let's make it u into 32. Okay, so let's try that now. Okay, so instead of that let's include that standard int int.h. okay, and yeah, printf also it should ask, right? Why it didn't give a problem for the printf? Yes, it is asking for it. Okay, so printf.h is also done. Okay, then let's try to do clean build again. Now it is asking for in function the undefined reference vport intercritical. Okay, so now we are not seeing the getting the reference for this vport intercritical. So this thing, so I think we need to define by ourselves. Okay, so let's define this also. We'll define this. I think this is already defined in port.c, but it is not able to take that. Okay, let's check whether port.c has this definition or not. Control Z, sorry. Let's see whether it's here or not. It's defined here, but it is not able to find it. It means this file is not getting compiled. Okay, so we have to check the make file. Why port.c is not coming? Port.c is inside our arc64. Okay, so arc64 included is added, but let's check the build whether we are doing it for port.freertos.c lib freertos, and here we have added for .s file. Okay, this is the problem. So this is not inside ARM64. It's the folder is GCC. Inside GCC ARM ARC64. Okay, here also ARC64 is there. Okay, now it should be able to find that. Okay, let's try. What it is saying, undefined reference to be port. Now we have added right inside AR64 all the files port.c, right, and that file is inside port.c only. So apart from here we have to add somewhere else also, undefined reference to be port critical enter this object file where it is used while building this FreeRTOS. Fine, while building this FreeRTOS, this object file and FreeRTOS lib has been again built using this FreeRTOS object files. Okay, FreeRTOS lib, this is also fine. Okay. Why it is given it like this? That's why it is not coming right. So control V, this is the advantage and disadvantage of directly using the suggestions. This is I'm okay, correct. Okay, now let's build it again. So now we are seeing different kind of errors. Okay, at least we passed that stage. Now it is asking no real to make port.c needed by FreeRTOS lib. Okay, let's solve this. So it's saying port.c. This port.c we have added the build rules here, right? Okay, here also the problem is there. Okay, so just one minute. Here also we have to paste ARM64. Now it should see the rules to build the port.c also. Okay, let's build it. Okay, so now that file is getting compiled, port.c. Okay, and let's remove this error. Okay, now let's do the clean build again. Okay, so now we are seeing different kind of error. What is that error? File format not recognized. Okay, so here we have to fix this line number where it is. Yeah, so this one we have to fix it with there is a command error, so this one we have to do add $@ and then this FreeRTOS. So now let's try clean it, then build it. Okay, so now we are clearly seeing some of the undefined reference to the idle hook. So now this idle hook we have to define in the FreeRTOS tick-config.c. So this idle hook, let's define this things inside FreeRTOS tick. Okay, so this to define this, let's see, just to give me 1 minute. The function which is required is memset. Another things which is required is undefined reference to memset only and v application get timer task. So these are the functions which you have to define explicitly. Okay, so the one is mems. Apart from memset, there is a v application get timer task memory. Okay, so let's I have the definition for this. I'm just searching. Okay, so that this definition actually you can get it from internet also online. Okay, and these functions are also given in the user guide of the FreeRTOS because these are required. Okay, so let's directly put these functions here. Okay, so this one will complete v task timer delay, then undefined reference we have to give the v configure tick interrupt. Okay, this we have to basically now give this one. Actually you have to write it. Okay, so I will explain this function also. So this function, what we are trying to do, so inside this function we are trying to initialize a timer. That init timer also I will show you where is this function, and then we are trying to set the tick rate, and we have IRQ control. Inside that IRQ control we are trying to route the virtual timer to core 0. Okay, so virtual timer to core 0. For that this is that interrupt routing we are doing. After that this CN. Okay, so this CNTB is big. Okay, just 1 minute. Yeah, so this CNTV is used to basically enable the ARM timer. Okay, I'm just printing the register for the debug. Okay, this init timer also we need to add it. I think I have not shown the init timer function, that also will write while porting this driver. Okay, so till here it is done. Now next this vconfig interrupt is done. V application, now next is V application IRQ handler. Okay, so this V application IRQ handler also, let's bring it to this one. Okay, so this one also you have to write it by yourself, because this is what will be called by your interrupt table. Okay, so here V application IRQ handler, here we are passing that core 0, what is the source of core 0. Okay, and then using this we are finding the interrupt ID. Okay, if it is there is a hierarchy count, this is just to print the hierarchy count. We don't we can comment this if that interrupt ID is vectored, that we vectored timer, then basically we are printing the IRQ count and also calling the FreeRTOS stick handler. Okay, this part we can comment it for now. Okay, so till here it is fine. Now we have to define this is already coming from here, so this IRQ handler is also fine. Now we have to define the FreeRTOS vector table. So here it is asking for the FreeRTOS vector table. Okay, so this FreeRTOS vector table we have to define. So let's see if we have any .s file. If it is not there, basically we will define the .s file, and that .s file basically we have to include in our build, or otherwise we can define import asm.s also. So this vector we have to, let's define here only. Let's go to the bottom of this file. Okay, so here we have to define this FreeRTOS vector table. What does this this vector table is the table which will load inside the v bar el1. So whenever any exception occurs, the first based on the exception ID, the first this is the first place where the CPU jumps. Okay, so let's define that exception vector table. We have to align exception vector table. Okay, let's align it, and then let's define this vector table underscore FreeRTOS vector table. Okay, inside FreeRTOS vector table we have to define the entries. Okay, so v3, this is where it will jump to. Okay, FreeRTOS SWI handler. Okay, so total 16 will be there. Okay, so this is the first one, that this one will be whenever synchronous exception at el1 in thread context will occur, it will jump to this FreeRTOS SWI handler. Okay, synchronous el1 thread context. Okay, next entry would be FreeRTOS IRQ handler. Okay, so this one will be called when IRQ will be generated. Okay, so this one also is in the thread context, so we'll first write all the thread context where it will jump in case of thread context. Okay, then we'll go in the handler context, that basically exception interrupt context. Okay, FIQ invalid el1 thread. In case of FIQ it will jump here, entry FIQ invalid el, it should not be el0, it should be el1. Okay, so FIQ el1, FIQ invalid, so this one will be basically error el1. Why invalid el1, FIQ invalid el1, FIQ el1 thread. Okay, then this one will be error invalid el1, then error el1 will be created. Okay, now similarly thing we have to write it in case of handler context. Okay, so I'm just copying and pasting it here SWI handler. In case of this one will not thread, this will be handler context. IRQ also, this one will be handler context, and FIQ also handler context, and error also handler context. Okay, so this is same FreeRTOS SWI, FreeRTOS IRQ, FIQ invalid, and error invalid el1. Okay, now copy for one more context, and this one will be during sync. Okay, so we have a sync invalid. So these error bits you can see in the in case of in the army 53 army A53 register sheet, right? So all these bits have has been defined. Okay, so let's define here EL1 and 64 bit. Okay, this is synchronous 64 bit EL1, synchronous 64 bit EL0. Okay, this is basically application level IRQ will be whenever the exception will be created from the EL1, that is application level, then it will be jumped to this one, and this one will be in case of 64 bit context. Similarly we'll have for 32 bit also. Okay, so next will be IRQ invalid, invalid EL0 64, and this one will be IRQ 64 bit EL0, 64 bit EL0. Okay, next will be FIQ invalid EL0 64, and FIQ 64 EL0, 64 bit EL0. Okay, after this we'll have error invalid EL0, and that also in case of 64 bit, so error 64 bit EL0. Okay, so this thing will delete. Okay, now same thing will be there for the 32 bit EL, same thing for 32 bit registers. Okay, so we have to just replace it by 32, and then 32. Okay, and here also in comments also you will mention it, and this will be 32. So while porting the FreeRTOS, this is the most important from where your tick handler or any kind of tick handler will be called. Okay, so here mostly the one which is useful for us is this SWI handler and then the IRQ handler. Okay, so after this vector table, basically this v tree we have defined, right? So this v tree we have to define also. Okay, so v tree is nothing but just a label, and that will define here. So let's define, sorry, so v tree is just a label, and that level will be jumped based on this, and after this, for each whatever we have defined in this vector table, we will have a corresponding table to basically if it is not handled properly. Okay, so let's define that. So basically to define, because other things we have defined, but let me just do, see, this SW and IRQ is defined, but these things are not defined, so these things will be, we have to define it. So let's define that. Sorry. Okay, so we have defined that also. So our vector table is now done, FreeRTOS vector table. Another thing what is required is undefined v application IRQ handler. Okay, let's see whether we have defined this or not. So in FreeRTOS config we have defined it. Okay, so let's do a clean build again and then see if any other errors are coming. Okay, so we have defined some of the macros in the FreeRTOS config.c, so that's those macros are not defined. Okay, so let's go to FreeRTOS config.c, and here we need one header file also to basically define these macros. Okay, so let's include the header file hash include not FreeRTOS. We need FreeRTOS config.h only will generate FreeRTOS config.h. Okay, and this header file we will add inside the include FreeRTOS config.h, basically just so that okay, let's copy this so that any macros which is defined here we can define. Or other thing which we can do is we can basically define here itself tick handler. Why it is saying it is not there? Just 1 minute, copy it and let's paste. FreeRTOS tick handler is already defined in port.c, and port macro.h has the definition also. Okay, so instead of port macro.h will include here port macro.h. Other thing is this instead of defining that at some other place, we'll directly define the macro here only. Okay, we'll not create a separate file. So this one is not needed actually, whatever is defined in line number 77. This one we can comment. This one was for the debug purpose, right? So this part we can comment it. Okay, and CNTV reg is also not required, line number 59. Okay, print CNTV. Okay, this one is also not required. This we just added for some debug, and it's saying that config.c, it's not able to find the static task. It is not able to find. Okay, so FreeRTOS config, we have to add some tasks. We have to add some of the headers at the top that we have not added. Let's add that header also. So hash include freertos.h and then task.h, and apart from this I don't think we need any other else. This timer we have not defined. Let's see whether we have defined timer or not. So these things basically we have to define. Okay, so init timer is not defined. That I will basically define it. So init timer will define in this file only. Okay, so basically we have to that arm per core timer, right? We need to initialize. So then that function is basically we have to, there are some CNTVFRQ that we have to load with the whatever we already read. So we will first read the frequency at which that timer is running, and the timer we have to write it to that CNTV register. Okay, so this will initialize that timer. Okay, ARM core timer. Okay, so init timer is done. Then we have to set tick rate. Okay, this one also we have not defined. So this one also let's define it. Okay, so here let's define these functions also. So here we are just reading it, and based on at what rate we need the tick interrupt, that rate we are dividing it and writing inside the CNTV. So basically every this rate we will be calling at inside this function only, where we are calling, yeah, in this tick interrupt. So we want it to be ticking at 1 millisecond. The timer we want to fire at every 1 millisecond, so that's why we are configuring that tick also. So this is initialization. It will read at whatever rate the timer is ticking and write it. Okay, that will initialize the timer, but we want that timer to be ticking at to be fired at every 1 millisecond. That's why we are modifying that rate here. Okay, next will be we have that timer should generate interrupt. So there is an interrupt controller that we are going to use the virtual interrupt which should be routed to the core 0. So that address we have to define, and this address I think I have already told you it is available in this file, ARM2836 IRQ control. Okay, so if you see this, not this one, yeah, so inside this one, right, core 0 timer interrupt control. So that address we have to define is 0x4000 and 0040 in hex. This we have to define. Okay, so let's define that also. So we will define in the same file. We will not create any separate header file. Okay, so let's go at the top of this file and just define that. Okay, so IRQ control is also done. Timer is also done. This config tick rate will come from the FreeRTOS config.h. We need FreeRTOS config.h because that's where we have defined, right? That's where we have defined that variable. So let's see if it shows that error again, and then we'll define it. Okay, let's do clean and run again. Okay, so it is saying that it is not finding the declaration of write CNTV well. Okay, another thing is it is not finding the timer tick. Okay, timer tick, and this globals also will copy and enable write CNTV and enable CNTV. Enable CNTV, is it showing any problem? No, right? So, and for reading the, okay, let's copy these 3 functions and paste inside this. So we have defined the CNTV value. That's the current counter value that we have to basically write it, and enable CNTV function. And enable CNTV, have we written it twice? Just let me check. Control C, Control F. No. Okay, so this one is done. Then this frequency is also defined. Okay, now let's build it again. It is showing error. In which file it is showing? Port type unknown, FreeRTOS config.c, and port macro.h. It is showing size t is not defined. Okay, size t is not defined. Okay, another is the expansion of the port macro stack here. unique must be set to the unique priorities implemented by the target hardware. Okay, that also will define. Or read this function. Read function is also not defined for reading the this frequency. So this also we have to define. Or reading the CNTV counter. V is basically virtual counter. Okay, so this one will solve this, make clean, and then okay. So now fix this. We don't need to import this port macro.h because port macro will have a dependency on other things. Okay, so this one will remove, and let's try building it. Make clean above this factored level. Okay, so this handle entry will be basically whenever it will come, we have to define okay, kernel entry it will go, and then it I don't think we need to define all this. These are just for the handling the invalid entry. Okay, let's define it so that if any error by default exception comes, we should be able to see the ESR and ELR registers. Okay, so for this again we have to define the kernel entry, and then this invalid entry message. So invalid entry message we have to define, and the kernel entry. Okay, so let's define that also. So that invalid entry message we are defining in one of the C function. So here we are defining in port sm.s. So inside port.c, but we need printf again. Okay, let's define it, then we will change it. If it is not suitable at this place, we will change it to some other place. So let's define this. We need a type un32t, and then this one also we will change to un64t, and then un64 address. Okay, so this one is done, and then we have to printf error message. Okay, so it will come from that entry error message. Okay, so entry error message also we need to define. Okay, so we are keep on going in that loop. I think let's not print add this. We'll remove this from port sm.s also. So here just error hang will define. Okay, it will go there and just stop it there. Okay, that's it. I'll just define the error hang. Okay, and so invalid message will not jump to that. Okay, kernel entry also will not go there. Now let's compile it. So undefined symbol. Okay, these symbols are not defined. Why these symbols? Sync invalid EL1. Sync invalid EL1. Where is this sync invalid EN port SM449? Okay. Wait. What is this? Sync invalid EL1. It's just 1, 2, 3, 4. Available at one of the bits, right? Key, which based on which bit will be generated, then we will jump to this one, right? So this macro we have to define. Let's define that macro in port macro.h. At the bottom of this file we'll define this these macros. Okay, and so a new file will define entry.h. okay, where we will basically paste all the contents of this one, and then we'll remove that from the port macro.h. okay, and after this this entry.h will directly include inside the port asm. Okay, this we have to include inside port asm. So let's include that inside the port asm. So can I include it at any place? Let me try. Yeah, it should be fine. Okay, so now we are seeing some other errors. Okay, so here what it is taking undefined reference to memory. These are the functions. Since we are not using standard lib, right, we need to define all this. So let's go at the bottom of this function and define this two functions. Okay, so string length, this you can either take it from internet or you can write by yourself memset, just setting it to 0, right? So apart from this we need one more clear tick interrupt. This function, yes, this function definitely we need to define. Okay, so this function will basically update your timer value. Okay, so that when the next timer should again fire, only that it will update. Okay, so let's define this also. Okay, now let's build it again. So inside we have not undefined. Okay, so this is the definition of this function you can get in the FreeRTOS technical reference manual. Okay, these are the functions you need to define it explicitly. Okay, so I have those functions definitions already, so I will just copy it from there. You can get it from the PDF. FreeRTOS, there is a FreeRTOS user guide. Inside that, definition of these functions is already there. Okay, so I will just copy it from my where I have already defined. So one is FreeRTOS get idle tick hook, then application stack overflow also needed. Okay, v application stack overflow hook, v application stack overflow hook. Okay, let me first copy this that get idle task memory. We'll paste it here. This you will directly get, no need to I will not go inside this, just take it from there and paste it here. And next is a tick hook. We have to basically this tick hook we need. Okay, so let me here we are not doing anything inside the tick hook. Okay, just will paste that function. Just it's a definition to bypass it. Okay, tick hook and stack overflow we need, and idle hook we need. Okay, stack overflow also we need. Okay, so let's find the stack overflow definition. Stack overflow also is nothing but it will print it and go inside infinite loop. Okay, so next is idle hook also is needed. Idle hook also we have defined it. That idle hook also we don't have to do it much, just a blank definition. Okay, blank definition of this also. Okay, now let's compile and build. Make it clean and let's build it. Okay, so now we have successfully built the kernel8.img. This kernel8.img I will basically inside main function we have written something or not. Yeah, we have written the task to print the task one is created. Okay, so based on this now let's so as you know this image has been built. Now we have to basically insert transfer this kernel8.img to RPI, and then I will jump to through TFTP, and then we'll jump to this kernel. Okay, so let me configure the let me first connect the RPI. I will open the picocom and then we'll transfer. Okay, so I have connected the picocom. Okay, let me just connect it from here. Yeah, so picocom UART console is coming, and now I will power up the RPI 3P. Yeah, we are seeing the U-boot console, so we'll not it to we'll press some key so that it stops the auto boot. Next would be we have to copy this image from so this image we have to copy from this one to TFTP boot. Okay, so this is that kernel image kernel8.img. Okay, so I will open one terminal here, and basically it will do scp of this kernel8.img. Sudo scp kernel8.img. Let me see, we have already scp command to transfer. Yeah, so we'll do it to TFTP boot. The IP is this one. No, only thing is we have to give kernel8.img. Okay, so it is transferred now. So it is transferred now. Now what we have to do basically from the from this TFTP boot, it has already sent to TFTP boot, right? So now I can directly do TFTP command in the U-boot to copy that kernel image 1 2 3 4 to the RPI RAM. Okay, kernel8.img, and let's see whether this TFTP is working or not. So yeah, so it has detected that file, it has transferred that file. Now let's read some memories which we have loaded, and then we'll jump to that location just to see what is happening. Okay, expectation is it should create thread, but mostly it will not happen. Let's see. 1 8 1 2 3 4. Okay, yeah, so task created successfully, but we can clearly see that okay, so we are seeing the print still here, task created successfully, but after that it has gone in the while loop. Okay, why this while loop is needed? We have to go inside the FreeRTOS, right? Okay, so we are not giving control to the FreeRTOS scheduler. That is the problem. Okay, so whatever is coming, it's fine. Right now it is fine only, because here we are stopping in a while loop. Okay, and whatever will be sent, that will be received. Okay, so now that will work like this. So f send, whatever character will send, same thing it will send on the UART. That's what we are doing. So instead of doing this, we have to give control to the FreeRTOS scheduler. Okay, so for that basically we have to uh, basically instead of going in while loop, there is a one function, okay, v task start scheduler. So we have to write this v task start scheduler instead of this. Okay, so let's do this change. I will comment out I will comment out this part, and we will give the control to scheduler. Okay, it's showing also v task basically start scheduler. Okay, and after this print should not come. Scheduler started, it should stuck there only. Okay, but just for debug purpose, I am putting if this print has come, then scheduler has basically exited from there. Okay, so while one, so this is fine now. Okay, let's build it here again. Let's do clean build, make it. Okay, so it has been copied there. Now let's transfer it again to the TFTP boot. Okay, so the new build image we have transferred here. Now let's load this kernel image to this RPI. Okay, I will unplug and plug the power cable again to get the U-boot console first, and then we'll transfer that using TFTP. Okay, TFTP kernel 8.img. Okay, so it is detected, it will transfer to this location. Oh sorry, I have not given the location. Okay, so let me give the location TFTP 0x8, otherwise it had copied to this load address. Okay, 1 2 3 4. Since in linker file I have given this as a start address, that's why I'm loading this kernel image here. Okay, so let me load it here again, and after loading I will read some of the contents. 0x8 1 2 3 4, and post some bytes I'm reading, and after that we'll jump to this location. Okay, let's jump to this location. 1 2 3 4. Okay, so we can see clearly there is one exception which is getting created, that is at line number. Why at line number it is saying as u? So a shirt has been called. Okay, at portable GCC port C at line number u. Why line number it is not showing clearly? Okay, maybe that stack I have not set up properly, that's why. So that line number also comes from there. So inside port.c we have to basically check why this assert is coming. FreeRTOS portable port.c. So inside port.c have we added anything? Oh, there's a config assert is there. There are multiple config asserts, but one thing, let me check why it is not printing line. Okay, that stack has not been set up or what. Okay, let's find at how many places assert has been called in this file. Okay, assert, if assert defined. Okay, so at a lot of places config assert. Okay, so it has been defined at multiple places. Okay, building for execution as a guest. Okay, I think we have not defined the guest, and it is trying to put at EL3. That's why this assert is coming. I think mostly it is coming from this line number 334. Why that assert? Okay, so this guest macro, we want to run this inside at an exception level of EL1. So since we have this guest is not defined, that's why it is running at this. Okay, so now let's define this in makefile. So makefile, we have to define this macro hyphen t करके we define it, right? Basically we add this define just 1 minute, we add this guest definition to our makefile. Okay, we have to add inside compiler options, we have to add it. Okay, so let's add inside compiler option, let's add it here only. hyphen d and UEST guest equal to 1. Okay, and let's build it again. Make clean, maybe we'll okay. So it has built successfully. This compiler options is already getting used, right? Yeah, so just to make sure, inside port.c, inside port.c, if it is defined, okay, config asset. So here I will just put error to check whether this macro is getting defined or not. Okay, yeah, so it's getting defined, so let's remove it and let's build again. Okay, so now we'll copy this image again one more time. Okay, so actually we go through these many iterations to just port it. That's why this transferring that kernel image through TFTP is very helpful. Otherwise you have to insert it multiple times, and sometimes that UART, because of some loose wiring or something, UART console also doesn't come up. So it's better to make the hardware stable, then you do everything through that SCP and TFTP. Okay, so now let's we'll do power off and power on again. And actually I should set up the stack also so that we can get clearly exactly which line. Okay, sorry, I forgot to press any key, so that you can see the line number also, right? Okay, so it's ready here. Now TFTP 0x address at which we want to load, then kernel 8.md will face the issue again. Then we will basically fix that stack also. Okay, now let's read this. 1000 bytes are also fine. Let's go to this location 1 2 3 4. Okay, so task created successfully. Now that error has been gone, but it had stuck at some other place. Where it has stuck, it's a silent hung, so this one will be a little bit more tricky to see. Okay, let's see where we are printing this. I think during timer init we are printing this. Okay, CNTFRQ. This we are printing during timer init. FreeRTOS tick config. This is not printing. So during init timer, after init timer we are not seeing any of this. Okay, so how to debug this? Basically, is it that some other exception has been created after this? Writing CNTV, this timer is defined, right? So it has read it, it has printed the timer. So by default it so one more thing, while debugging you are getting clue, right? By default when it boots up, that ARM timer runs at this 19.2 megahertz. Okay, so but we want, if it is run at this, then if we will not reconfigure the rate again, you will get a tick interrupt at a rate of every 1 divided by 19.2 megahertz, whatever time it will come. During that time, that timer interrupt will come. Okay, no tick interrupt will basically fire in FreeRTOS. So that's how basically I'm telling you, this is how we basically debug. So now we are seeing a silent hang. This will be a little tricky to debug, but I will still go through it, how to fix this. Okay, so okay, this debug information gave some info, right? At least that's why we add some debug infos. Okay, so I think this init timer, okay, this init timer is called from where? That also I will show you. Control F, Control V. Okay, this is called from the whenever we are configuring the tick interrupt. And okay, so configuring the tick interrupt is basically creating this problem. Okay, and what about I can show you. So next this one will, from where we are calling this vconfigure tick interrupt. Let's see that also. So it should be called from the, okay, so this macro is actually replaced with this config setup tick interrupt. Okay, so now we have to search for the from where this setup tick interrupt is getting called, then we'll find out what it is trying to do. Okay, so setup tick interrupt is getting called from here. So okay, so here only we have added it as a guest defined as 1. And okay, what is this function? This function is basically, okay, starting the scheduler. So whenever it is going to start the scheduler, here we have exception level. Okay, here also we can print the exception level, right? So here we are getting the exception level inside this, right? So it is not now this config assert is not getting called because our we are trying to get it at EL1. Okay, and but after disabling, whenever it is trying to do that ISR setup, then only it is creating this problem. Okay, so next thing would be okay, next thing basically, since it is related to interrupt, we have to check whether we are enabling interrupt or not. Okay, so let's check that. So now we have to check whether this tick interrupt, why this is causing the issue. So we can, let's print some stats in the main function, and then we'll see because of what this interrupt is creating the problem. So basically we'll try to read the interrupt controller of that core timer, and then basically from that we'll try to figure out. Okay, so let's write one function inside this main, and that function will basically help us to finding some more debug points. Okay, so just I'm defining one function, get the interrupt stats. Okay, inside that I will just print the IRQ counter. Just first I will printf the function name. Okay, after this printf interrupt stats, and then why this D, I don't printf stats. Okay, this is fine. Sometimes this suggestion is irritating also. Okay, so printf I will try to print the IRQ control value, and then IRQ source also. So these two things will print. Okay, core 0 timer IRQ control, IRQ control will print, and then we'll also print the IRQ source. Printf will print the core 0 then IRQ source. Okay, these two things will basically print, and we'll print it in this macros we need to define. That macro will define, but we'll print it in hex format, 08x. Okay, so this one also I'll print it in hex 08x. Okay, and these two macros we will define also. Okay, so these two macros are actually just one second, we'll define it here only, IRQ control and IRQ source. Okay, so that this we have defined at some of the place. Let me see, control C, control V, we have to okay, we have defined in FreeRTOS tick.c. Okay, we'll define it here again, hash define IRQ source, IRQ source first it is. Okay, source IRQ control should be 40, and IRQ source you have to check this source also. You can core 0 IRQ source as it is at 61, 60 and 40. Okay, so these are fine. This will basically print the interrupt stats. So this one you have to basically call at before creating the task, or maybe after creating the task also I'll print it. Control V, and then okay. Apart from this also I will add all the CNTV timer registers, read all the timer registers and print those timer registers also, so that we can get some more clue about what is happening. Okay, so that I already have this, that I will copy. So this CNTV reg, this I will just copy the definition of this one. This function also you can define in FreeRTOS tick config.c, but I will define it here only. Okay, since we are not using there, we'll define here in this function. Okay, like here we'll define here. Okay, now let's build it one more time. If we still don't get it, we'll see the startup code also, because I think startup code we have not checked. So I think the startup code I have taken same what we have used for the bare metal, and I need to, let's verify this one also once. So basically it is finding the affinity, jumping to master for core 0. Okay, this hypervisor we are at EL 2 only, so we are not at EL3 registers. This is fine. That EL2 settings we are configuring hypervisor configuration, then SPSR, then we are jumping to EL1 entry, and inside EL1 entry we are basically setting the BSS start begin, and then the stack pointer we are moving to this okay, stack pointer also we are setting it, and then we are jumping to the kernel main. So this should be fine, except I think problem would be, I think one more thing, this V bar EL1, right? So if you see V bar, there is a register V bar EL1 where we basically transfer the vector address to this V bar EL1. So that any why I'm suspecting this, let me clarify, because since as soon as you are initializing the timer, you are getting silent hang, right? That silent hang can be a flood of interrupt, or maybe whenever it is created, okay, during that time the FreeRTOS doesn't have context. If any exceptions are generated, FreeRTOS doesn't have any context where to jump to, okay. So because this task context switch happens at a different time, okay, but as soon as you initialize the timer and the current time has already passed, then it will immediately generate the timer interrupt, and on generating the interrupt it doesn't know where to jump to. We have given the address, but since it has not come till this function vport restore task context, it doesn't know. So that's why I want to initialize this vbar el1 also with this FreeRTOS, okay, so that it's just doing same thing twice, but just to make sure ki it has that vector table, so that the CPU knows where to jump to whenever any exceptions, whenever any IRQ or any other kind of exception occurs, okay. So that's why this thing I will do in the startup.s also, okay. So let's do that, okay. And other thing would be inside this boot, not inside boot.s, there was one more .s file, right? Yeah, port asm.s, okay. Inside this only we are modifying, right? We have added some vector entry table. So here also I am directly going to the error hang. Here also what I will try to do, we'll try to jump to that assert thing, and whenever this kind of error comes, we can print ESR and ELR, okay. Okay, that is also one thing we can do, okay. Okay, so let's first set up the vbar el1, okay. After setting that we will basically look for this one, okay. So let's at the start of we'll set it for both el1 and vbar, we'll set el1 and el2 both, since so inside boot.s, right, since this start we are not loading arm stub, we are we'll be booting from the exception level 2, so we'll set up both of the vector table, okay. So let's just set it and start of this file. This is finding the affinity, we'll do it without jumping to anywhere else. So let's set the FreeRTOS vector and base, okay. Well, FreeRTOS vector table, okay, and this vector table will load inside the x1, okay. FreeRTOS vector base, okay. We don't need to do at el2, el3 we have to do in el2 and el1, okay. Same things we have to do in x1 we have loaded, right, like this. MSR same we have to do it el1, okay. And after this basically we have to do the DSB ISP, so that it should not try to for fast enough, right, ARM CPU, what it try to that it so that it maintains the instruction execution flow. That's why you have to do DSB SY synchronized, and we don't need to do DSB, ISB will be enough, because data we are not doing anything, right. So SY, okay. So this both things is fine. Now let it jump based on, let it find it for each of the core and then do, that's fine. So let's build it again, make clean, and let's make the binaries, okay. So this is explained, right. I'm just trying to avoid one condition. Maybe by the time it initializes the timer, interrupts are enabled, it is trying to find the where it should jump to, but it is not finding that address. Now I'm giving that address, okay. So that's why this is important, okay. So we have already built it. Now let's transfer this again to the same TFTP boot, okay. After this let's see on, let's try to power switch off and switch on this RPI 3B, which should get the U-boot console, okay. Now load using TFTP 0x81234 kernel 8.img. So after this let's read some bytes, and then we'll jump to that location. At least it will give some clue to us, okay. So still that it is not finding that vector table, But what we are seeing that IRQ control should be 0, source is 0, CTL is also 0, C value is this one. This is about our interrupt stats, and this is about CNTV val. Okay, so still we are seeing a problem with this, that it is after creating that CNTFRQ, it is not jumping anywhere. Okay, so to make sure that this has been compiled, we can check the list file. Okay, where this list file, or yeah, list file should be okay. We can copy and check the list file whether okay, yeah, so you can see this VBREL one is getting copied, so this should be fine. So it knows this at least address, the vector table. Okay, so that is not creating problem now. Now what we can do, either we can, after this init timer, it's going for toss, right? Basically it's a silent hang. So after this print, we are while writing to this timer, it is creating a problem. Okay, so is it because of writing this, since it has read it and it is trying to write it, clear CNTV interrupt and set okay, set next 1 second timer, 1 millisecond timer, man, 1 millisecond timer. Okay, this timer CNTV, what it is trying to do, we'll check this one. Okay, it's trying to access EL0, so that should be fine. After returning this init timer, okay, just I am checking, maybe one more thing can happen, since that UART is printing till there, maybe it's not the one which is creating this problem. It may be after init timer, whenever we're trying to do this or trying to write to this IRQ control, that is creating the problem. Okay, so have we added any print inside this function? No. Okay, so what we'll try to do here, since we are trying to write directly to an memory address, okay, maybe this can create a problem. Maybe this can create an exception which we are not able to find. So this is directly writing to a memory mapped register, right? Okay, okay, so we have not configured the MMU, and you are trying to write an address which is not inside RAM, which is there inside the peripherals address. So that peripheral address I have not mapped it, so this can create a problem. Yeah, so this can create a problem. Okay, so okay, how to prove it? Basically what we can do, we can print this one and put a while loop here once, and next time we'll put while loop here. Then we can figure out whether this one is causing that problem or not. Okay, another thing is, since we have in case of any other exceptions, we are not printing what kind of exceptions it is creating. That's why we are not knowing not knowing the reason for the silent hang. Okay, so what we'll try to do, we'll try to print it here and add a while one here, so that we can get this print, and we'll make sure till here it is not creating any problem. Okay, so this is while one I have added here, and just inside this function I will add one print function. Okay, at the end, printf decreed. Okay, yeah, this should be fine. No need to return. Okay, so this should be fine, and after this it will basically loop here, so that we can get the UART print till here. Next time I will add a print here and then put a while loop. Mostly that print which I will be putting after this line should not come. Okay, so basically it looks like the memory which you are trying to write, you have not mapped it using MMU. Okay, so okay, it's mostly that issue only. Okay, so let me first build it and show the output of this, then we'll check on the other part. Okay, so let's power off and power on again this RPI 3B. Okay, so tftp 0x81234 kernel 8.img. Once it is copied there, okay, so now we'll just read some bytes. Okay, after that we'll jump to that and then see whether we are getting those prints or not. Okay, so timer tick we got, right? Timer tick we are getting, right? So see, okay, copy. So our confusion, whatever we suspected, that was correct only. So timer tick we are printing, right, in printf. Yeah, see, so it is coming till here. Okay, it's coming till here, and it is showing that divide by that one. Okay, so it is coming till here. Okay, so let the controls, and now let me show you the next thing. So after this it is printing, we are able to get that print because we are putting while loop, so it is not creating immediate exceptions. Okay, now same thing, what I'll do, I'll remove the while one here, put a print function here, printf, and just I will give just some after timer interrupt routing. Okay, and then I will print, I will add a while loop. Okay, so if this one is not causing a problem, then this print should come, and it should come directly here because it has reached till here. Okay, so now let's build it and again see. So let's go to this one, scp. Okay, done. Now, so this is, you can see, right, how fast it is to build it again, and you can check the binary, right? So for starting, you may need to do multiple experiments. You have to make it work, right? You have to do a lot of things, a lot of time you have to invest in. Okay, so please subscribe to this channel, so that whatever time I'm investing it. These are all the way to debugs, right? And see, that silent hung is the worst what you can get. You will not have any clue. Okay, since I know these kind of issues, that's why I'm able to okay, even if I would have not known, that's how I will debug. I will put one by one print. I will see some of the core timers, interrupt registers, till where it is failing. I will keep putting debug prints. From there I will trace it. Okay, that's how we debug in the embedded system. Okay, but if you don't have any costly debugger, those are very costly debuggers. We are just trying to debug using UART, nothing else. Okay, tftp081234. okay, kernel 8.img. now we should see the print which is mentioned, which we have mentioned here, right? This print should come. If it is not coming, then this is causing the problem. Then we have to work on the MME part. Okay, so it has transferred it. Now let's read some bytes, and after that we'll jump there. Go to 0x81234. After timer interrupt routing, so this one has also come. So this is not a problem. Okay, this is not a problem. Now we have to find, then, this is the problem. Okay, so after this core, after this thing, basically now we have to correct. Now we have to find out. Okay, this one is not a problem. Now we have to find, is it happening after this enable CNTV? What we are trying to do, let's see. Okay, MSR CNTV. Okay, this one we'll look in. Okay, after this we'll try to read the IRQ control, and then we'll also try to see after enabling CNTV what is the problem. Okay, so I suspected this is the problem, but no, it's not hanging immediately after this. Okay, so other thing which I will do is okay, so this is fine, printf is fine. Now after writing this, what I will do, I will print the IRQ control which we have defined in the main.c, right? Inside main.c, this functions we have defined. So this function CNTV interrupt states. Okay, so what I can do, main.h also I can define, and that I can include it here. Okay, so let's create or do one thing. We'll move these two functions inside FreeRTOS tick config only, and then we'll create a header. Okay, so FreeRTOS. Okay, so let me put it here first. Okay, now I will create we need headers. Okay, so that header can you create here, but if I will create here, that project is not finding it, right? So FreeRTOS tick config.h I will create. Whatever I was avoiding, now we have to create FreeRTOS tick config.h. okay, inside this, basically whatever we are going to use, right, these two will define it. Declare this inside this header, and another is this one. Okay, Control C. Okay, so this headers we have to include in main hash include include free FreeRTOS tick config.h. okay, so here it is fine. Now inside tick config.c we'll read the interrupt stats. Okay, we'll try to read the interrupt stats. So where is that interrupt stats? Interrupt stats we'll try to read here. Okay, and after this CNTB should be fine. After enable CNTB, okay, now we are trying to read it after this, and also we'll after CNTB also we'll read the CNTB CN and the functions, other function which you have copied, right? So the other function interrupt stats print CNTB reg. Okay, this one also will read it after this. Okay, so this is fine. Okay, so it was already commented. Okay, now to find out the exception, right? So inside port asm.s we somehow ignored this key. Instead of printing that message, we ignored this type, because control C control F in case of any other exceptions if it is coming. We want to know what kind of exception it is coming. Okay, so let's define the function using which we can basically read what kind of exceptions has occurred. Okay, so now this has become important. Okay, so let's define this handle be entry type. Okay, so we have defined it. Only thing is we are not showing the error message. Okay, so let's branch to this invalid entry, and before that we have to save all the registers. Okay, because we are jumping to the interrupt context, right? As soon as the exception comes, we should first save the temporary registers. Okay, so that's why that kernel entry I am defining it, and that kernel entry we have to define that macro also. Okay, so let me define that kernel entry macro also, and we have not I think FreeRTOS SWI handler is here only, but just I will check that. So this one, this kernel entry also we should define it. So this is the kernel entry where it will save all this temporary registers onto the stack pointer. Okay, FreeRTOS SWI handler should be already present in this file. No need to do extern, right? Yeah, so no need to do extern of this. Okay, so now at least we'll get some message. This s-frame size is defined or not? This should be defined, right? So this should be defined. There is any entry.h frame size we have defined it, but we have not included. We will include that entry.h. Oh, we have included, right? Okay, so that we would have included entry.h. Okay, let's include little bit early. Okay, so okay, this is fine. Frame size stack, then show invalid entry message. Okay, now we have to define this function also. This function we have defined or not, basically to print. Okay, so this function we have not defined, we have to define this function also. Okay, so this function we can define in the same FreeRTOS tick config.h. okay, so basically it will okay, so apart from this we have to define okay, so we have to define this whole FreeRTOS tick config.c will define we'll define at the bottom control v. Okay, so only thing is this one u in 32 then 64 then 64. Okay, error code printf error message. Yeah, so this should be fine. Now let's build it. So where it is saying IRQ source, it's not defined. Line number 93. Okay, this line number 93, this we have defined in main, right? So source and control, this both will define inside control x inside FreeRTOS tick config.h. That's our main header file. So from here everybody will get it, and this we have to include in FreeRTOS tick config.h here also. So any macro which we have defined here temporarily, okay, it will show that error. So here we have to define include config.h. Okay, now let's do a clean build. Okay, so any error warning is fine. Oh, warning is fine. This warning is because I'm building in guest. Okay, so that is not a problem. This should also work. So we have built it. Now let's copy it, and then we'll try the kernel image. Okay, so fingers crossed. Let's see whether it gives any clue or not. Okay, tftp 0x81234 kernel8.img. So it will copy to this location. Now we'll just read some locations from here, and then we'll jump to that location. So let's jump now. Okay, so interrupt stats, IRQ interrupt control, core 0 interrupt source. Okay, so timer interrupt is coming. CNTV CT val, this D24. Okay, so this value to E4, so this current value has increased this compare value, so basically the interrupt will come. Okay, CNTV T val. Okay, so we have still not found anything. Okay, so what we have done, CNTV, so we are able to see CNTV CT val. So where is our this print we have added, right? Not mem copy init timer. Where is our init timer? So CNTV, it has occurred after this, so basically it is going out from here, and this tick interrupt is getting called from where? This is getting called from okay, this is the macro for the opposite one, and this one is getting called from here. Okay, so maybe the problem is not inside this. Whenever we are trying to restore the task context, then the problem is starting. Okay, so let's just see this vport task context. So vport task context is defined in the port ASM. Okay, so we need to global, this is a global. Okay, it is defined from here, so we have to basically, okay, after this it is jumping to port restore context. Okay, Control C, Control F. We have to debug it here. Okay, so this issue is still there. So one thing I think it's there in this port ASM, right? Inside port ASM, it looks for the register which is stored in this ICR, and this is generally available when you have GIC. Okay, so let me find the address of this. Okay, and basically this will not be available because in RPI 3B we don't have the GIC. Okay, so this one, instead of reading this register, we have to read the register for which is available, interrupt source register we have to read instead of this. Okay, so for that basically we have to read the core 0 interrupt status. Okay, so this one we need to modify, that's why it is not finding it. Another thing would be, it could be MMU, but that will verify after this. Okay, NDR, then it should be copied, X2 should be copied to one register will add, one address will write, core 0, we have to tell the intr src constant. Okay, so src constant, and then X2, so this part we will comment it because this is not available, and this use ul core 0 of interrupt src constant, this one we have to define it. Okay, so to define this we have to first set at the bottom of this file, okay, from where it will read. Okay, so let's define this at the bottom of this file. Okay, so that definition is at the bottom. So instead of this one we have to basically define this constant dword source, and this UIR is fine, we don't need this part. Okay, and then again we have to define that U0 interrupt source. Okay, so this one we have to define, so let's define this one. We will define this one inside FreeRTOS, inside we can define inside port.c. so port.c, we have this port.c, right? Inside port.c we can go at the top and define this wherever that other registers are defined, right, which is getting used in the same place, we'll define this one also. Okay, so we task context. Okay, so here, right, so these are the interrupt acknowledge registers, then end of interrupt IRQs. So instead of this, we need to define the core 0 interrupt source, so that will define here. Okay, so let's define that here. Okay, so after defining this, any other definition I don't think we should have to do. So after this, let's try it once. And another thing which I found in this port asm.s is, if you go to this one, right, so there is a FreeRTOS abort, that whenever there is a, because of some exceptions, FreeRTOS abort is getting called, we can put a debug function. Okay, so here, right, FreeRTOS abort, or just search using abort. So it is jumping to that current location again. Instead of that, we can give debug function where we can print the all the exception registers. Okay, those exception registers, if we print, then that will help us in basically debugging key what issue is happening. Okay, so instead of that, we can define one function exception which will basically print the registers. Okay, so that also I want to change here. So this one will change to branch to this exception handler, default exception handler. Okay, this is the default exception handler. Now we have to define it. Let's see whether we have defined it or not. Okay, since we have not defined it, so we'll define it to this one also. This one also will define in the FreeRTOS tick config. Okay, so nothing, it will just print all the exception types and everything, all the debug information which we need it, and those debug information will be helpful for us for debugging. Okay, so directly I will add at the end of this FreeRTOS tick config.c, and now let's try to build it. Okay, so what is saying, it is not able to find the default exception handler. So the same function, let's define inside the header file, and let's define inside the header file FreeRTOS tick config.h, and that header file we have to include inside this function. Which function? Port asm, right, where it is getting used. So this port asm, just so inside this default exception, it is saying it is not able to find the getDL function. Okay, so getDL function, it is not able to find where it is trying to. Okay, getDL function. Okay, this is for getting the exception level. Okay, this function will define it here. Okay, so getDL function we have to basically define, right, so let's define it here only. Okay, so actually it should be defined inside okay, let's define it, and then we will declare it inside here, and automatically linker will find it. So let's define it inside we are using port asm.s, right, so here itself we can define getDL function. Okay, and that getDL function, okay, let's define at the last. Maybe if it creates some, it will not create any problem, but let's define in the last of this file, just reading the exception level, right. So I have defined it, and we can just declare it inside FreeRTOS tick config.c. Here we will define that getDL function. Okay, so what it will return, you will return unit32 getDL, that's it. Okay, now let's build it again. Yeah, so build it, and okay, so now let's copy this image to our TFTP boot, and then we'll load this binary. Okay, so let's power off and power on the RPI 3B to get the U-boot console. Okay, so now do tftp 0x8 1234 and then kernel 8.img. This I do this location because before this, starting locations are actually reserved. Okay, so you cannot copy to that location. Okay, so let's read some data from this, and then we'll try to jump whether this solves the issue or gives some clue by using that application default exception handler. Then we can debug more. Okay, so assert is getting called again. Okay, assert is getting called, but the change which I did was uh, it is showing assert is getting called in line number u. Why line number is not coming, that is one thing, but why assert is getting called. Okay, so we are not able to find the line number here. Let's see. Okay, it's percentage lu. Let's try with percentage t only. I think with that at least we will get the line number because of which that assert is coming, and then we will debug. If it gives some hint, right, then we'll try to do that. Okay, so this is copied, and now let's copy it again. Okay, it has been copied here. Now let's plug in again. So we are getting the U-boot console. So now do again tftp 0x81234 kernel 8.img. After this we'll read some bytes of data 0x81234. After that we'll jump there. Okay, so here we can now figure out it's line number 435. So FreeRTOS port, it's there inside port.c, right? Yeah, so port.c 435, port.c line number 435. Okay, so inside FreeRTOS tick handler 435 if not defined chemo. Why this is getting called if not defined chemo, then usable interrupts priority. Okay, why this port ICC RPR running priority register, this should be equal to the port lowest usable interrupt priority shifted by port priority. Okay, let me check why this assert is getting called. If not, okay, so this one is inside port.c, right? So I will check in port.c. Okay, so this part we need to comment it down. Okay, then after commenting this down, any other things defined assert equal to 1, port ASM maximum API call priority is fine, and then config tick interrupt. Okay, this is also fine. Okay, so let's try after commenting this part. Okay, so these parts let's comment it, and then we'll again build it and then load it again. Okay, so build it. Now let's again copy it. Okay, we have copied it. Let's power up again and then see what happens. So this is done. Now tftp 0x8000 840's kernel 8.img. okay, after this we will read some bytes. Okay, after this we'll directly jump to that location. Now see what new thing is coming. Okay, yeah, so we can successfully, we are able to create the thread, and that thread is getting scheduled every I think every 1 second. Yeah, so basically we have kept some delay of 1 second. Let's go to main.c. inside main.c 1000 millisecond means 1 second. Okay, so as you can clearly see, right now we are that thread is successfully printing that hello from the task 1. Okay, and since we are not putting counter, but you can clearly see here, okay, it is coming from this thread only. Okay, so this completes our tutorial. Means now I will build anything on top of this. Okay, so please go through this. This is how we debug. While any RTOS porting to any of the board. Okay, so thank you so much, and please subscribe. Thank you. We are clearly saying hello from the task 1. I was thinking to add one more thread, and both threads should print this one after another. Okay, so what I will do, I will just copy this and again paste it, and then this will be task 2, and print from task 2. Okay, hello from task 2. Okay, so these two threads again let me create that task variable task wait, so let's create the task 2, and task 2 also will create, and after creation, so task created, this is for task 1. Task 2 we are checking, task 2 creation. failed, task 2 created successfully. Okay, so with this now we'll see both tasks. Okay, so let's build again, and we'll copy this to TFTP board. Okay, after this we'll copy using TFTP. Okay, and now I will turn it off, and again plug the power for RPI 3B. We are seeing the U-boot console. Now we should see 2 threads running. Okay, so TFTP 0x81234 kernel 8.img, and after this we'll just read some of the values, md 0x81234. After reading this, we'll directly jump. Now we should see 2 threads getting scheduled. Okay, so go to 0x11234 and then just go. So okay, yeah, so it is coming from 2 threads, but okay, so here the problem is, this problem I will solve in a separate video. By the time task 1 is printing, task 2 print is also coming. That's why we see some of the prints from the task 1 and some of the prints from task 2. Okay, so this problem I will solve using one of the OS components in the next video. So please subscribe. Thank you.